Hello everyone, welcome to the channel. So today we'll be solving this problem of the day in LeetCode. Today is 20 January 2026. So uh, let me give the problem description. So we are given an array nums of consisting of n prime integers. You need to construct an array answer of length n such that for each index the bitwise or answer of I and answer of I plus 1. Okay, so this is not answer of I plus 1, like it is not an index, it is outside of the uh, answer of I. So it should be equal to nums of I, uh, as it is given as well. Okay, now we want to find out, we want to minimize each value of answer of I in the resulting array. So let's see the problem. So I have drawn some examples and all. So this is for the problem description. We are given some nums. We want to, it will contain elements A1, A2, A3, A4. We are given an answer which will contain X1, X2, X3, X4. Now the we want to find X1, X2, X3, X4 such that X1 or X1 plus 1 should be A1, X2 or X2 plus 1 should be A2, and X3 or X3 plus 1 should be A3. Okay. Now these are the constraints which are given. So one thing is nums of I is a prime. Then nums of I is between 1000 and okay, the lowest value is 2. And nums dot length is 1100. Okay. So what can be the maximum? I mean, what is the what can be the time complexity which is was and which will get accepted? So if we saw big of n times 1000 will get submitted in that, okay? So for example, what is the maximum value of n? It can be 100 in the worst case. And what about the 1000 is, I'm talking about this thing, okay? The maximum value of nums of I that can be 1000, okay? So 100 times 1000, okay? So it the time complexity will be 10 raised to 5, which is less than equal to 10 raised to 8. So it will definitely get submitted. Okay. So why am I talking about this? You will get to know later. So now let's jump onto the problem once again. So we are given that nums of I is a prime. So I have listed down all some of the prime numbers: 3, 5, 7, 11, 13. They're binary representations. These are they're binary representations. Okay. Now, if you now as we want to find out x or x plus 1 should be equals to some number. Okay. Let's say that number is a. So I will go to the example once again. So for 5, you can see that the answer was 4, right? Why? Because if we see, like, what is the binary representation of 5? The binary representation of 5 is 4. The answer was the answer for 5 was 4, right? The binary representation of 4 is 100. Okay. Now if we take an OR of take OR of, like, this was the answer, right? So if this is our x, so x or x plus 1, that is 5, what will it be? Okay, the binary representation of 4 is 100, binary representation of 5 is 101, and their OR will be, focus on this bit, this will be set, this is unset, and this is 1. So it will be 101, which is binary representation of 5 itself. So the answer will be 5. We got 5, right? Okay. So for 5, the answer was 4. For 3, it is given that in the problem, it is given that the answer is 1, right? Because for 3, the answer is 1. Binary representation of 1 is 0, 0, 1, or we can say 001, or we want to find out 1 or 2, right? X or x plus 1, that is 2. Okay, what will it be? Binary representation of 1 is this. Binary representation of 2 is 0, 1, 0. Okay, so what will it be? It will be 1, 1, and 0. So now if you see, this is 2 raised to 0, 2 raised to 1, 2 raised to 2. So 2 raised to 2, 2 raised to 1 plus 2 raised to 0, which is 2 plus 1, that is equal to 3. This is binary representation of 3. Okay, so we can say it's 3. We got our answer, right? We want to find out such smallest x such that, let me, write the expected value. So the expected value is find smallest element x such that x or x plus 1 will be equals to a. So for this is for each a. Okay, so for each array element, where here a is an array element. So we can say if you think upon examples, you will get to know that for 2 whose binary representation is 1, 0, it is never possible to find such an element, okay, where x or x plus 1 uh, will be 2. Okay, you can try out by yourself, like if you say that 1 or uh, if you say 1 or 3, I mean, if you take 1, x is equal to 1, 1 or 2 will be 3. Okay, 1 or 2 will be 3. This will be 3. If you take x is equal to 2, 2 or 3 will be, as you can see, 0, 1, 0 or 0, 1, 1. This is binary representation of 2. This is binary of 3. There or will be 1, 1, 0. So this is binary of 3 only. So the answer will be 3. If you see for, if you take x is equal to 3, you know, it will be definitely I mean greater than equal to 4. So this value will be greater than equal to 4. This value will be greater than equal to 3, because of the fact that uh, the fact you should know that x or y should is always greater than equal to max of x or y, max of x comma y. Okay, so you should know this property, so you can solve to be able to solve that. Now, if you see 2 or 3 will be greater than equal to 3, but we want 2, right? So this could have been the possibility, like it was greater than, could have been greater than equal to 2, but we got it as 3, so it may not be possible. Okay, if this is not possible, below things will not be possible, because this will be at least greater than equal to 3. This will be at least greater than equal to 4. Again, 4, 5, it will be at least greater than equal to 5. So for if with this facts, we can say that answer for 2 is not possible. So for 2, the answer will be always -1. Okay. And also, let's focus on the binary representations of the prime numbers now. Okay, now we could get to know that, like for 2, the answer will be always -1. Now, for the other numbers, let's focus on the primes. Okay, let's check if it is possible or not. Okay, for 3, uh, let's check if it is possible. Like if I have written all their binary representation, like for 7, the binary representation is 111. 11, it's 1011. 13 is something like that. As you can see, there is an there is an 1 at the last bit, okay, because the number is odd. As you know that every prime number except 2 except 2 is odd. Okay, otherwise it will be divisible by 2 and it will not be a prime. Okay, now if we subtract 1 from them, okay, if we just take their previous element and their binary representation, what will happen? Just subtract 1 from them. Okay, so you should know the subtraction of binary things you may have learned into your school or college. Okay, let's subtract 1. Okay, I will not tell much examples. So let's for this example, if we subtract 1 from it, so this is binary representation of 3, this is binary representation of 1. Okay, this is 0, 0, 1. Okay, we want to subtract 1 from 3, so what will happen? Let's check. Okay, 1 minus 1 will be 0, 1 and 0. Okay, what about this? This will be 0. I mean, if we subtract, this is binary representation of 5. Okay, let's take this element 1, 0, 1. We subtract 1, we get 0, 0, 1. This is binary representation of 4. This was for 5. This is for 7. For 7, if we subtract it, we will get 1, 1, 0. Okay, for this is for 11. If we subtract 1 from it, we'll get 1, 0, 1, 0, which is binary representation of 10. Okay, because this is 2 raised to 1. uh, as you can see, 1, 0, 1, 0. This is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So the answer will be, for which bit it was set, 2 raised to 3 plus this one, that is 2 raised to 1. So this will be equal to 8 plus 2 equals to 10. Okay, now you can after getting their previous element, what happens is, okay, you know that their binary representations are something like this. Okay, for 3, the previous element was 2, its binary representation is this. For 5, the binary representation of 4 was 1, 0, 0. Now you observe, if you take all of these two elements, okay, we will always get this element. Okay, why this is happening? Because you are just setting this bit off by subtracting 1, and this is an odd number. Okay, so this will become 0, right? This will become 0. So for every odd number, the last bit is becoming 0, right? It's getting set to 0. So what will happen is 1, 0, 0. Okay, uh, for as you can see, this bit was set to 0. For 11, this bit was set to 0. And that's why if you take all of them, what will happen? This will be set. Okay, every element which was set, every bit which was set in this element will be set. Otherwise, it will not be. Because what is the difference between this and this thing, right? Only difference is that the rightmost bit was set in this number, but it is not set in this number. Okay, so even if we take their or of these elements, so this is I mean, this is 10 and 11, right? This is 12 and 13. If we take or, like, let's check upon 12 and 13. Like, our x is 12, whose binary representation is this. It's or with x plus 1, that is 13. It will be, if we take or, we'll get the same number, 1, 1, 0, 1. As you can see, this is the same number. Okay, you can try and other examples by yourself, and you'll get to know that why this is happening. You will get your intuition now. Okay, as we are clear, we just want to check now if this is valid, or if we can get an element x such that our we get an a. Okay, so what can we do is, we can, as we saw that x or y. So in this case, we want to take or with x plus 1, right? X or x plus 1. It will always be greater than equal to x plus 1. So let's say For 2, what will be up to which x should we check? Okay, so I will say the rightmost, I mean the rightmost x that we will check is 1, because 1 or 1 plus 1 will be greater than equal to 2. Otherwise, if we say it for 2, okay, if we say it for 2, the answer will be greater than equal to 3. Okay, so which will not, but we want answer of 2. So okay, that will not be a possibility. Okay, so what we will do is simple brute force. Okay, for each element ai, so let's say for our I is going up to the is looping into this. Now for int j, so I will store this element. So what is the element? X will be, let's not call it x, let's call it e. E will be equals to arr of, I mean nums of I, right? Now, okay, we want to find out an element such that there or is this the element x such that we want to find out x such that x or x plus 1 will be equals to a, right? And as we saw that, what will be the maximum for each x, what will be the maximum number that will be checking? It will be x minus, it will be only x, because x or x plus 1 will be greater than equal to x plus 1. Otherwise, it will be greater than it will be greater than equal to x plus 2. I mean, any element which is greater, if we take any element which is greater than x. Okay. And now, so I think that's it. I think we can, okay, now for each element, as we saw that, what we want to check for int I is equals to 1, okay, I less than equals to, this is a, right? We'll only loop up to a, I plus plus. We'll get to know, we want the smallest one, right? So whenever we got an, so let's not call it I, let's call it x, okay? So whenever we get an element x, okay, we just have to check this condition. If x or x plus 1, okay, let's make it like this, is equal to a, then our answer, let's, so this is temporary answer, so let's call it as, I mean tmp is equals to -1. I mean it will not be in the comment section. Okay, we get temp is equals to -1. Now what to do is just check if this is valid. Now if we get this number, we know that our answer will be x, and we will immediately break it because we wanted to find out the smallest one, right? So now as we are out of the loop, so we are out of this loop, okay, this if was closed at this thing, right, was closed at this, and this for loop was closing at this. So after getting out of the for loop, we will just push back this uh, temp into our answer. Okay, I hope you got the logic. There were a lot of things. If you don't understand, watch it carefully and try to use your brain as well. So we'll code it, uh, code the solution. So first let's define nums equals to nums dot size. Now what we want to do is we want to return a vector, right? So let's define the answer vector. Now for for int I is equals to 0, I less than none, I plus plus, our a will be nums of I. Now, as we saw that if our a is 2, uh, we will directly push the answer for 2 will be minus 1, right? So as you can see, the answer for 2 was minus 1. And in the else part, if it is not 2, then of course there will be an answer because it is a prime and it is odd. So definitely we will get an answer. We will get an answer. So how to find that answer? Okay. So as I said, we will take an temporary variable minus 1 for the safety. If even if we don't get any answer, its answer will be minus 1 as stated into the problem description as well. Okay. So we will start x from 1. Okay. We'll start x from 1, x less than equals to a, x plus plus. I have described why it is only a. Okay. Now, if we get, as I said, x or x plus 1 is equals to a. Okay. This is our answer. So temp is equals to x, and we will immediately break the loop. Now it is out of the loop. We will simply push back into our answer the temp. Even if we don't get it, we will, I mean, definitely we will get it, but in case if we don't get it, uh, we will push back minus 1 into the answer and we'll simply return answer finally. Okay, let's check if it is valid. Yeah, we got accepted. Let's check if it is getting submitted. Yeah, as you can see, it bets only 43%. So why it is why it is slow? Okay, because this loop is running n times. Okay, this loop. Now in the else part, this loop is running how many times? It is running from 1 to a, right? And what can be the maximum value of a? It is 1000, right? So that's why our time complexity of this code will be 1000. I mean, this is n. What can be the time, or what is the worst value of n? It will be 100. Okay, because it's num size 100 times uh, the maximum value of a, which can be 1000. It will be 1000, which is equals to 1e5, and which is less than equal to 1e8. Okay, uh, that's all. Thank you so much.